At this point, we have looked at relations, and we've taken a look at a special type of relation called a function. Now let's recall for a moment that a relation is a subset of a cross-Cartesian product or a cross product, and all this means is that if A and B contain some elements, and I'll just keep these really small, 1, 2, and we'll say B contains the elements little a and little b, then the cross product A cross B would be the all possible pairings, all possible ordered pairs that you could generate, where the first element comes from set capital A and the second element comes from set capital B. If we had B cross A, it would be the other way around. So in this case, we'd have, for example, 1A, we'd have 1B, we'd have 2A, and we'd have 2B. Now that's the entire cross product, but a relation, remember, is some subset of that cross product. So it could contain as few as none of those ordered pairs, and it could contain as much as all 4 of those ordered pairs. And we know that a special type of relation called a function, and I'll kind of come back to codomain and range here in a moment, is a mapping. Remember, the name of the function is, in this case, called f, and it is a mapping of elements from set A to set B. And so all that means is that set A is going to be our domain, and B is going to be called our codomain. Okay, now, so what does that mean? Well, in the context of codomain, it's the set of all possible values in B. And remember that the range is the values in the codomain that are actually mapped to. So we could have a codomain that contains 30 elements, but not all 30 elements are being mapped to from the domain. In other words, not every output has a corresponding input. Furthermore, a function can have one or more of the following properties. So today, right now, we are after the properties of a function, and every relation has a certain set of properties, right? If a relation is such that every element in A is paired with only one element in B, or better yet, exactly one element, that would be a better word here, exactly one element in B. In other words, if I give you an input, you should be able to give me exactly one output. That's the definition of a function. So that's a special type of relation, because in some cases we see that in this cross product, the input of 1 has an output of A, but the input of 2 also has an output of A. I'm sorry, I should have said the input of 1 has an output of A, but the input of 1 also has an output of B. So if I were to say, hey, the input in the domain is 1, what is the output? There isn't the output, there's actually 2 possible outputs. And this Cartesian product is not a function, because there exists an input that has 2 distinct and different outputs. Moreover, a function can have one of 2 properties, or potentially both of them. It could be an onto function, or it could be a one-to-one function. So notice that the first thing is that we have a relation. Everything is a relation. And then from there, we could either be a function. And if we are a function, then we could have one or both of the following properties. We could have onto, and we could have, I'll just write it like this, 1, 2, 1. Okay, so everything's a relation. Some relations are functions, some functions are onto, and some functions are one-to-one. An onto function, sometimes called a surjective function, it's just terminology. A function is called onto if every element in the codomain is mapped to by some element in the domain. In other words, your codomain and your range are exactly the same. So if the codomain was the set of all whole numbers between 1 and 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if every element, 1 through 10, had a corresponding input, then we would say that that function is onto. If, however, let's say we had the elements 1 through 10, but only elements 1 through 9 were mapped to by some input, well, then the element 10 is in the codomain, but it's not in the range because there isn't an input that maps to it. We would say that it is not onto in that case. Similarly, every output, if I give you an output, you can tell me exactly what input generated that output, then the function would be 1 to 1. So in other words, it's a function going both ways. Every input leads to exactly one output, and every output leads back to exactly one input. That's called a 1 to 1. One input to one output to one input. The type of function that's called 1 to 1 is called an injective function. So typically you'll hear people say it's a surjective or it's an injective. And if it has both of these features, if you're both onto and 1 to 1, then you are what we call a bijective function. Let's take a look at a couple examples where we'll map all of these concepts and see if we can get this terminology straight. So domain is, and we could kind of draw a circle around these, or a little oval to generate our domain and codomain. So remember, we always map from the domain into the codomain. Easiest way of looking at it. So the domain in this case is the set of elements A, B, C, and D. The codomain is a set of all possible elements that can get mapped to X, Y, and Z. The range, okay, the range is the set of elements in the codomain that have an arrow pointing to it. Well, all of the elements in the codomain have an arrow pointing to it. So the codomain and the range, notice, are exactly the same. Well, that by definition is an on-to function. So every input, notice, has one output. There's only one arrow coming out of each domain value. So that makes it a function. And it's on-to, so yes, each input, I'll just write this one time, each input has exactly one output. A common point of confusion with functions is, well, C and D both point to the same output. Well, that's not a problem as far as a function is concerned, because C, that input, only has one output, namely Z. The input D still only has one output. That value is Z. It just so happens that two inputs lead to the same output. That's not problematic in terms of the function. So yes, we notice that the codomain is the same set as the range. 1 to 1. Okay, so now 1 to 1 says if every element in the range has exactly one element in the domain. Okay, so now we have to kind of look at each output and see how many inputs does it map back to. Well, X leads back to exactly one input, A. Y leads back to exactly one input, B. However, here's our problem. The output of Z actually has two arrows coming off of it. If you imagine this going the other way, Z leads back to C and Z leads back to D. So that violates the definition of what we're calling 1 to 1. If every element of the range maps back to only one, again, I like the word exactly, one element in the domain. So this is not 1 to 1. No, Z has two inputs. So in other words, we could say that f of C equals Z and f of D equals Z, right? That's where that becomes a problem, that mapping of two inputs to the same output. It's still a function, it's just not a 1 to 1 function, because one output corresponds to two inputs. That's an easy way to remember what 1 to 1 means.